Hello everybody, today we're going to be going over flying the quadcopter that we created in the last video and adding real-time GPS and also going over real-time video alongside that. So as always, let's go over a quick overview. We'll then dive into our requirements, then we'll go into design, into the different attachments, how everything was actually physically built out, and then we'll go into our software configuration, and then ultimately we'll show some results of just some generic flying, video streaming results, and then GPS results as well. So problem overview is to build and fly the QWINOUT DIY drone kit with the provided flight controller and provide real-time video feed via Wi-Fi to a host computer, as well as providing GPS. So our requirements, again, like we talked about last time, were to assemble it, calibrate, demonstrate hovering, pitch, yaw, roll, and then do our FAA registration, and then also adding the video camera, GPS module, configuring local Wi-Fi for the host machine and the Raspberry Pi. So just a quick reminder, the Raspberry Pi is physically on the drone, connected to the different sensors on that drone, and the host machine is the machine we have connected to view that data from. So again, we'll have to configure our Raspberry Pi to connect and stream video via RTSP, connect it to the USB GPS device, and then make that GPS data streamable to a third-party device or our host machine. So going over our simple design here, we can see we have it just built out. We have a flight controller on top, and then we have our battery, and then that's connected to our main breakout for the ESCs and the brushless motors. This is the bare bones. This is before we add in the Raspberry Pi, GPS, and camera. So let's look at what it looks like once we add those in. So we can see we added a Raspberry Pi attachment on the bottom here, and that's just zip tied on. Just so it stays stable, and then we also have a zip tie back here to one of the legs to kind of add a little bit more stability as well. The video camera is attached with another zip tie, and it's just a simple ArduCam video camera. They're just smaller, so it's a little bit easier to get onto the platform, and that's just attached back here behind the battery. So keep going forward. I did end up taking the power module from a mini PIX and soldering on the converters for the Lipo, which is right here. That then goes to the breakout to the main ESC/brushless motor board, and then we have soldering over here to connect to the buck converter, which will be used to power our Raspberry Pi. In the next video, we will be converting to the mini PIX, which will then be powered through this board as well. So our GPS component was really simple. I just tied it onto the leg, didn't notice any problems with that at all, and then ran the wire USB cable through one of the legs up to the Raspberry Pi. So manual build instructions, same as we talked about last time. The only difference this time is, like we talked about, we added a video camera, we attached the Raspberry Pi, we soldered the power module, and we added T connectors and XT60 connectors to convert from the LiPo batteries connected to our buck converter connector. So the software configuration for the Raspberry Pi is as followed. We started off by downloading the Raspberry Pi imager, which then we used to configure the Pi to connect to a cellular hotspot. So on boot, it'll connect to that cellular hotspot. This made it really easy to get it up and running in the field. And then once we had that configured, we also used the Network Analyzer cell phone app, available for Apple and Android. And we were able to scan our networks to figure out its IP. Once we had the IP, we SSH'd into the Raspberry Pi and just did some simple updating. We installed git docker compose, and then we cloned down the my drone sensor suite repo, and then we just built out the docker compose and ran docker compose up. This set up an RTSP feed on 8554/PyCam, and then it set up GPSD. For the host configuration, we started with VLC to view the stream, so we just went and downloaded VLC and connected to the RTSP stream. And then for GPSD, we viewed that via Telnet and then also through the sensor web server, which was another git clone. And then we were able to do uh, the install and then npm run dev on both the backend and front end folders. And then from there we navigated to localhost 3000, the drone sensors tab in the navigation bar, and we're able to view that data correctly. So scrolling down to the results, we can see we have a VLC stream here showing the RTSP feed. Viewing, we can see we even have a little drone down there. The camera is mounted towards the bottom, so that's why you see it like that. And then we can also see myself right there. And then going to the GPS results, we can see we have a telnet session stood up. We can see we're connecting to the box or the drone, and we can see we have some lat long there as well. And then on the web server, we can see we have some points on the map for where we flew for our initial demo flight. So now let's look at some live video to view the working end product. On the left, we can see that we have Telnet connected to the GPSD, and then we can see we're starting to walk with that RTSP feed from the Pi going. We're still getting some GPS on the left. To the actual flight footage, where we can view how bad of a drone pilot I am. We can see on the right, it's a little bit ahead of time, but we pretty much immediately flipped over and ran